Is it possible to solve this integral without trigonometric substitution? Usually, with composite functions like the square root of some function, we like to take this inside entity as some u and go from there. In this case, du would be 2x dx, and unfortunately we don't have it. It's not the 2 that we're missing, we can simply multiply and divide by it, but x appears in the denominator in our case, and not in the numerator. In hopes of forcing this substitution, let's try multiplying the top and bottom by x. And then, if we try this substitution, we do have an x in the numerator. And as we said, to make up for the 2, we'll multiply by 2 and divide by 2 outside the integral. So the resulting integrand becomes the square root of u du, but then we still have an x squared in the denominator. We can solve for x squared from the substitution equation. This is u plus 1, and this is the resulting integral purely in terms of u. Okay, how can we solve this? Perhaps a substitution v equals u plus 1. dv would be du, and the integral in terms of v would be this. Still not getting anywhere. It seems like the original substitution we went for is not the best bet. Going back to this integral form, instead of having u be x squared minus 1, let's have it be the square root of x squared minus 1. The derivative of the square root of anything is 1 over 2 times this square root, but by the chain rule, we have to multiply by 2x. Okay, the 2 and 2 cancel out. The square root in the denominator is precisely u, and rearranging we see that u du is x dx. So we can replace this x dx over here with u du. The square root in the numerator is u, and again we solve for x squared. We square both sides of the u equation, and x squared becomes u squared plus 1. So we now have the integral of u squared over u squared plus 1. To solve this, we'll use more algebraic manipulation. We'll add 1 to the numerator, making it match the denominator, but then of course we have to subtract 1 again. I showed it in this way to highlight that if we split the fractions like this, the first one will reduce to just 1, and the second fraction has an easy antiderivative. All we have to do now is resubstitute u in terms of x, and with that, we've got our final answer.